Hello everyone, welcome back to our channel Elevate Learning Hub. Today we'll be discussing large language models. So let's get started. First we'll be talking about the large language models introduction, their definition, that how AI models for the natural language processing tasks could be used for text generation, summarization and Q&A. How they can facilitate human-machine communication by learning large language patterns, and why they've been called large because they've been trained on 100 million plus parameters on the extensive corpus of data. They're capable of processing and generating language for various NLP tasks, multiple languages, multiple LLMs and their models like BERT, GPT for natural language generation, then GPT 3.5, GPT 4, and so on. So we'll move forward on to this. First, we'll be focusing on that why large language models are called large, because they are pre-trained with a large number of parameters, approximately 100 million plus, on large corpus of text to process, understand and generate natural language text for a wide variety of natural language processing tasks. The large language model family includes BERT, which is Natural Language Understanding Model, and GPT's Natural Language Generation Model. The specific LLM models such as OpenAI models like GPT 3.5, GPT 4, they've been trained on billions of parameters and they've been exceptional performance in various natural language processing and text processing tasks. Now we'll be talking about what are the fundamentals of these LLMs onto a transformer architecture. LLMs are built on neural network architecture, particularly the transformer architecture. They allows basically to capture complex language patterns and the relationship between words or phrases in large-scale data sets. Large language models can also be understood as variants of transformer architecture. The transformer architecture relies on attention mechanisms such as self-attention, multi-head attention, which allows the model to understand the relationship between the words and the weightage of importance of different words or phrases in a given context. Now we'll be talking about what is self-attention mechanism. It allows each position in an input sequence to attend to all position in the same sequence. In other words, it helps to model to understand and interpret a sequence of by considering the entire sequence. For example, when processing a sentence, self-attention allows each word to be contextualized in relation with the other word in that sentence. We'll take it in detail. But before that, what is multi-head attention? Multi-head attention or multi-head self-attention in a transformer represents multi-head attention heads with where each attention heads learns a distinct attention mechanism so that the lawyer as a whole can understand more complex relationship between them. Now we'll be focusing what are the building blocks of neural networks of the LLMs. From the neural blocks of these LLMs, the transformer architecture represents the neural network model for natural language processing based on the encoder-decoder architecture, and the transformer architecture consists of two main components, the encoder and the decoder network. The encoder network takes an input sequence and produces a sequence of hidden states. For example, the encoder network takes a sequence of words in the source language. Example, we just now said that the cat sat on the mat. So while this is going to be an input processing, the encoder processes the sequence by each word, and each word is converted into a numerical forms like the vector in its meaning, which is typically done using the word embeddings. Now, when these transformer architecture, which is representing these neural network, does those processings and it understands the sequence of word for like the cat sat on the mat, which represents that each word is being converted into a numerical form, which states that as it processes each word, the encoder uses self-attention mechanism to understand the context of each word about every other word in the sentence, which results in a sequence of hidden states, and each state being a vector that encodes the contextual information of a word in that sequence. For instance, the hidden state of cat would capture not just the meaning of cat but also its relationship to sat on the mat in the sentence. The decoder network takes a target sequence and uses the decoder output to generate a sequence of predictions. For example, let's say the decoder network aims to generate the translation in the target language, says it starts and generate one word at a time, and using the encoder output, the decoder uses a sequence of hidden states produced by the encoder to understand the context of the source sequence, and it does the sequence of predictions as well for each word it generates, and the decoder uses cross attention mechanism to focus on different parts of the encoder's output. This helps the decoder figure out the words in English sentence are most relevant to the current words it's trying to predict in French. For example, when translating the cat sat on the mash to French, the decoder might focus on hidden states for cat when trying to predict the French word for cat, and it becomes an iterative process that each word is going to be generated in French, and the decoder that updates that state and makes the next prediction until the sentence is being translated. Now we'll be focusing on the types of the LLMs versus the transformer architecture. While the original transformer model consists of both encoder and decoder blocks composed of multiple layers of attention, the cross-attention and feed-forward neural network different types of LLMs may use variations of this transformer architecture depending upon their intended application. As a type, transformer architecture, which is being explained in the picture, also shows that there is represent a bunch of multi-head attention mechanism and that feeds the forward networks. Now we'll be talking about that there are multiple or types of LLMs models as we have discussed, and based on the architecture, basically all of these use encoder, decoder or both networks. The autoregressive language models like GPT, they use the decoder part of the transformer architecture, which is making them more suitable for natural language generation. Like tasks like text summarization generation, these models generate the text by predicting the next word in the sequence given the previous word, and they are trained to maximize likelihood of each word in the training datasets given its context. The most well-known example of an autoregressive language model is OpenAI. Now we'll be talking about GPT-4. It's being the latest and the most powerful iteration autoregressive model based on the decoder network, primarily leverages layers related to self-attention, cross-attention, and mechanisms, and feed-forward networks as part of the neural network architecture. Autoencoding models like BERT, which is on the other hand mainly uses the encoder part of the transformer. It is designed for tasks like classification, question answering, etc. These models learn to generate a fixed size vector representation, also called embeddings of input text, by reconstructing the original input from a masked or a corrupted version of it. They are trained to predict missing or masked words in the input text by leveraging the surrounding context. BERT is a bidirectional encoder representations from the transformer, which is developed by Google and is one of the most famous autoencoding language models. It can be fine-tuned for a variety of NLP tasks such as sentiment analysis, named entity recognition, question answering, and so on. Autoencoding models based on the encoder network primarily leverages layers related to self-attention mechanism and feed-forward networks as part of the neural network architecture. The third one is a combination of autoencoding and autoregressive such as T5, which is text-to-text transfer transformer, and which was being developed by Google in 2020. Then comes T5 LLM, which performs natural language understanding and natural language generation. And T5 LLM can understand as a pure transformer base which has both encoder and decoder network. Now we'll be focusing on a couple of the scenarios where we can use these large language models. While the traditional natural language processing algorithms typically only look at the immediate context of words, the large language model considers large text to better to understand the context. So here are two examples of the large language scenarios showcasing the use of autoaggressive and autoencoding LLMs for text generation and text completion respectively. Auto-regressive large language models, let's take an example that as we know that autoregressive models such as GPT generate a coherent and a contextual text based on the given input from, let's say the input to the autoregressive model, which could be that refine your mobile experience with its cutting edge technology and the unparalleled performance. So when you give this as an input prompt, the model which is being there does the auto encoding. And with this example of how the auto encoding model works, as learned earlier, auto encoding models such as BERT used to fill the missing or the masked word in a sequence which produce a semantically meaningful and complete sentence. Now let's see the input to the auto encoding model, which is with the example that LLMs are based on the neural network architecture, particularly transformer architecture, which allows to capture complex language pattern and relationships in large scale text data. LLMs can also be understood as variants of transformer architecture. The transformer architecture relies on attention mechanisms such as self-attention and multi-attention, which allows the model to understand the relationship between the words and then the way the importance of different words in each phrase. Now we'll be focusing on that how does the LLM work at the back end. They are the key building blocks and are composed of several key building blocks that enable to efficiently process and understand natural language data. The following are some of the common critical components, which is tokenization, which does the processing of converting a sequence of text into individual words, subwords, or tokens that the model can understand. In large language model, tokenization is usually performed using subword algorithm, which we say as BPE, which is byte pair encoding, or a word piece, which splits the text into smaller units that capture both relevant and the rare words. And then this unit helps to limit the model vocabulary size while maintaining its ability to represent any text sequence. Now moving on to embeddings. Embeddings are continuous vector representations of words or tokens that capture their semantic meaning in a high dimensional space. They allow the model to convert discrete tokens into a format that can be processed by the neural network. In a large language model, embeddings are learned during the training process, and results the vector representation can capture complex relationship between the words such as synonyms or anomalies. Now coming on to the attention mechanism, particularly self-attention mechanism used in transformer allow the model to weigh the importance of different words or phrases in a given context. By assigning different weights to the token in the input sequence, the model can focus on most relevant information while ignoring less important details. This has the ability to selectively focus on specific parts of input, which is very crucial for capturing long-range dependencies and the understanding of the natural language. Now comes pre-training. Pre-training is the process of training a large language model on large-scale data sets, usually unsupervised or supervised, before fine-tuning it for a specific task. During pre-training, the model learns general language patterns, relationship between words, and other foundational knowledge. This process results in a pre-trained model that could be fine-tuned using a smaller, task-specific data set, significantly reducing the amount of labeled data and the training time required to achieve high performance on various natural language processing tasks. Now we'll be focusing on the list of large language models, which we've been showing into the chronological release order. The light blue rectangles represents pre-trained model, while the dark rectangles represents the instruction tuned models. Models on the upper half signifies the open source availability, where those on the bottom half are the closed source ones. So these are the comprehensive overview of the large language models, starting from your T5, GPT-3, Lambda, ChatGPT, Gemini, and so on. Now in detail, we'll be focusing while we'll be comparing these large language models. If you want to compare the 25 approximately the large language models, which are the top one, we would be able to compare BERT, GPT-2, GPT-3, and we'll be able to compare them on based on their disk size, the training data GB, so which is there, and this is something which we would be focusing while we'll be comparing the large language models. Now we'll be quickly jumping on to when to use these large language model and when do I need these large language models to achieve any of my projects. Deciding whether that you want to integrate a large language model into your project, or you're evaluating for certain expertise in AI or large machine learning, it clearly defines based on your project goals what you want to achieve out. such as the large language model has a capability of advanced natural language processing, contextual understanding, generating human-like text, and it keeps in mind the capabilities that LLMs addresses your business problems which is there in hand. Like advanced natural language processing can understand and generate human language with high degree of sophistication. It also includes tasks like sentiment analysis, text summarization, and language translation. It does the contextual understanding, which is one of the key strengths of LLMs and their ability to understand context in language. They can infer meaning from preceding text, which is crucial for applications like chatbot, context-sensitive help systems, and personalized context generation. They also can do the generating human-like text. That large language model can generate text such that it closely resembles human writing or the content writing, such as writing articles, generating creative writing, automating responses in customer services, and it can analyze your data, which is most effective from dealing with substantial amount of text or complex linguistic text. It can access whether your data necessities has some traditional text processing as well. Technical readiness of the team, we can look out for the necessary skills which is being required from requiring to deploy these large language models such as the computational resources or the cloud services, and it does have its financial implications versus the decision that it would be needed to buy in. The large language models entail costs due to uses of API and infrastructure. It is very important to weigh these costs against the potential efficiency gains and the value additions that it brings into your services or product. You have to analyze the cost involving in implementing a large language model and the expected benefits that it will have, improving efficiency, accuracy, or the user satisfaction. From a compliance and the ethics perspective, the large language models, it aligns to the data privacy laws, additionally ethically considered, and the large language models ensures that it does not have any biases, and they gives more specialized tools where it can solve your complex problems as well. Now we'll be focusing on a couple of industry use cases. Like large language models nowadays help you with a wide variety of applications due to their advanced natural language processing, and here are the few of the most impactful use cases. So we'll start from customer service automation, where chatbots and the virtual agents with the help of the LLMs can power sophisticated chatbots and virtual agents that provide human-like interaction. They can handle customer inquiries, offer support, provide information 24 by 7, and it enhances customer experience, reducing the overall workload on the human staff. This use is applicable in different industry domains, example e-commerce, banking, and financial services and healthcare. Even from email and social media responses, it can give the automated response to the customer emails, and the social media inquiry can significantly improve the response time and building the consistency in the customer service area as well. By having multiple languages, by responding to writing emails and different purposes to sales and marketing. The second one that we'll be focusing is content creation and curation. Automated journalism. Now LLMs can write news articles, blogs, posts, and other written content efficiently, and they can also use to curate, summarize content from multiple various sources. They can go on creating writing that in creative domain LLMs can assist in generating ideas, dialogues, or even entire plots for stories, scripts, and advertising. Large language model also focus on the localization and multilingual translation as well. LLMs can provide high quality translation across multiple language and facilitate communication in global business and helps break the language barriers. Localization services. Beyond translation, LLMs can adapt to content specific cultures and locals, ensuring that these translations are culturally appropriate and contextually accurate. It also focuses on education and research. LLMs can use to create personalized educational experiences, offering tutoring, language learning assistance, and help in understanding complex subjects. It can also focus on academic research. In research, LLMs can assist in literature reviews, data analysis, and even in drafting research papers. Data analysis and business intelligence, sentiment analysis analyzes customer feedbacks, market trends, and social media posts to gauge public sentiment on multiple topics. It can also create business reports. LLMs can now synthesize vast amount of data into coherent and insightful business reports, market analysis, and executive summaries. These use cases demonstrate the versatility which large language models bring in as a cost-effective and efficient way. It enhances user engagement, creativity, and the overall decision-making process in multiple sectors. Now we'll be focusing on token-based pricing for these LLMs. Though this is extremely exhaustive, but you can see that one token is equal to 4 characters in Google Vertex, and then approximately input price price for 1 million tokens is approximately $1. And then when it comes to Azure OpenAI, it is also for $1 million. They've been charging $10 for input and output. They've been charging $30 right now. So this data we've been providing based on the statistics of April 2024, which will further improve when there are more versions it's going to be coming in. Now we'll be focusing on couple of the frequently asked terminologies or jargons which is being used. What is the difference between NLP and LLM? So NLP is natural language processing, and it's an AI machine learning techniques used to understand and generate human language. It encompasses technologies like speech text recognition and text analysis, wherein when we spoke today in the session on large language model like BERT, GPT, they belong to different family of natural language processing, namely natural language understanding NLU and natural language generation, which is NLG. These advanced models trained on vast text data sets specializes in generating coherent and contextually relevant text data. Now the next question that we frequently hear is, what are the most popular LLM models? So this we just showed you in the last slide. We have large language models like OpenAI GPT series, which is GPT-3, GPT-4, Google BERT and its variants like T5, text transfer transformer, then Llama. And these models stand out as advanced text understanding generation capabilities. What is the relationship between transfer learning and LLMs? Transfer learning is an integral to large language models. LLMs are initially trained on vast general data sets, gaining their broad language understanding, and this knowledge is then transferred and fine-tuned for specific tasks or domains, enhancing their performance in specialized applications without needing from scratch, thereby saving time and resources. Is ChatGPT a large language model? Yes, ChatGPT is built on a large language model such as GPT 3.5 or GPT-4, and these LLMs belong to the GPT series of which is generative pre-trained transformer family, specifically designed as autoregressive models. This means it predicts the next based word in that precedes it. GPT utilizes vast data sets and its algorithm to understand and generate responses that closely mimic human language, showcasing the advanced capabilities of autoregressive large language models in natural language generation. Now the next question which we frequently hear is how to evaluate different LLMs. So this is something which I would request that you can go on the evaluation of certain large language models. You have multiple pages like Stanford Helm or Hugging Face Open LLMs leader board, where they offers you matrices to make the comparison between large language models. Last one, what are the different LLMs parameters? So this we just now discussed, that the parameters guide tasks on like generation, words, then translation, and many more. So moving forward, we are going to be concluding this session today, that what all we spoke about, that large language models are powerful tools for natural language processing which quickly analyzes and accurately mimic the data, and these LLMs can be used for a variety of tasks like text generation, sentiment analysis, summarization, machine learning, classification, and many more. With the LLM's ability to quickly and accurately process large amount of data, they have become valuable tools for multiple processings across industries, and now natural language processing researchers and specialists specialize themselves in large language model, and they want to stay ahead. So natural language play a very important role along with the large language model. They enable machines to better understand natural language and generate more precise and accurate results. Utilizing the AI technology such as deep learning, neural network, these models can quickly analyze vast amount of data, and highly accurate results could be produced for multiple applications in different industries. So that's all for today. Thanks for watching, and would request you to please subscribe to our channel. Thank you very much.